Hello and welcome back to my channel again. So today we'll discuss on snake and ladder game, LLD problem. So a snake and game is simply basically the same which we discussed earlier, or you must have gone through many, or you have played a snake game earlier also. So we will try to get an optimized LLD machine coding code here with the best explanations. Starting with this, we will have the pattern which will contain such as singleton pattern and factory pattern, observer pattern, and strategy and command pattern. For singleton is basically used for uh, creating the instances of the board. Factories is basically used for creating uh, or creating the snakes and ladder of the board. And observer basically for we can let's assume that we have multiple players, and to let the player know or notify or get the latest board, we need observer pattern for that. A strategy pattern, we try to have a strategy pattern because we want to define the device rolling, and for that we need kind of a strategy which needs to be changed dynamically. And lastly, we can also have a command pattern. So command pattern, basically what we want is uh, we have to encapsulate all the requests as an object to privatize the client with queues and a request of the operations. So let's start with this, and we will try to uh, we'll try to not to have all any vag. We'll keep it simple. So first of all, we'll try to initialize the board. So inside this board, we can have public class. Okay, and we can have a private, or let's say why it is coming. I don't want Copilot to run my code. Okay, just a minute. Let it be. I'll try to complete by my own. So, what I'm planning to have in our board is we can have instances, we can have size, and inside what which we have laid ladder and snakes. So let's try to initialize that. So we can have a static because we want only static board, and that can be called without making object. Okay, I guess spelling is wrong. Okay. So after that, we can have size. Let's make this private again. In order to have snakes and ladder, what I'm planning to have is we just want the head and tail of the each snake and ladder. So we can store this in a map. So for that, we can have map and same goes for ladder. I'll just copy paste from here. Okay, let's have a constructor of the board, and we'll make this board as a private because we don't want another class to make change in this board in size. So this dot size and this dot snake new hash map because we want to have new hash map. New address is equal to new hash map. That is fine. Okay, so to make this class as a singleton, we can have another method which will get our instances and public static get if oh, 1 second, why this copilot is working? Can we stop it from here? Okay, I don't know from where to stop this. Wait a second. So let's do one thing. Let's check if instance is null. Then we will going to return new instance. Otherwise, will not. Otherwise, we'll return the instance which we already created. Okay. After that, what we can have, since we have the board, we can have the size of the board. We can have like get snakes, get ladders, and add snakes. We can also have since we have the initialize snakes and ladders, so we can add snakes and stacks and add ladders. So let's quickly add all these methods, and that method we can have at public itself. So that's not an issue. And this okay. We can have before that I can have get also now. Map get ladders, and we can also have add ladder, which will be same. Okay, no, this I don't want. This is to right. We can have key as a head and tail as a value. We can have a top. Let's rename it as a start, which make more sense. And we can have start and we can have end. Okay, so I think this class is we can go forward. So now let's quickly have a observer pattern. Okay, so in observer, let's do one thing. Let's make an interface first because I want to provide implementation for this interface. So what I'm going to do, observer basically will have one method which will be update. So it will take whatever the message or like whatever the log which you want to print. So the update will take care of that. So that I want it here. Now we can have a player class because we need to provide the or we need to notify the other players. So we can have a class called players which will implement observer, and this player will have a name and position. Basically, we need these two. Now we can have a constructor for this player. I'm not providing the position because position which we can update that. But to initialize this position, we can have initial as 0 because every position player will start with 0 itself. We can have now get position, which will return nothing but position. We can have a get name, which will return the name itself. Now we have done with this player. We can add a I can either we can have we don't need to provide a, set name, but we can have a set position and set position also, and also we need to have this update method implementation. So let's have that. Okay. So to have this update method, we need to have another function which will be update. So update will take care of giving the logs. So we can have system.println with name, position, or message. Because we can pass a message from here, right? Okay. So also we need to update it here because message can be anything. So we'll pass it directly from there. Okay. Also we are providing implementation. In that case, we need to override that. Now we can have another class which will take care of this player, adding player, notifying player. So that class will have naming as game. So now this game, so now in this game we'll have a board and player. So board which are already made the class, and player which we already have the class. So we initialize the game with this two, and uh, will not have this method. Instead of that, we can have add player. So first we need to add the players. So in this game, we will add the player, and we can have notify players, get current players, and turn next. So notify player will update this. I'll get the message from here, and I'll update this particular player with this message. We can have get current player, not void. It should return player. Get current player. We can also have who's next turn. We can update the next turn. So for that, we don't need any return type. We can directly update the turn. Current player plus one mod player or size. This is correct. So we'll update the player with size, but what if the size is exceeded? So for that, we are taking the mod. Till here, I guess everything is right. Why this is coming? Cannot be resolved for type. I guess we are not importing or what? Observer. Okay. Okay. So actually, we are using player, not a command player. I was thinking we are using player. Okay. How we get this player size? Okay. So to get this player size, we need to initialize player, not the board. Sorry, why I've written board? It should be player size because the game will contains all the players. So which should make it this as a private. That's why we should not blindly follow the copilot. Board we don't need because we are already having the board somewhere else. It's just a game, and game contains players and player current player. We can have that. We can update this player, or we should not have the players because it is getting added. here. So I'll update this player.add player. I guess everything is right then. We are notifying updating. Oh, sorry. So it should be end. Okay, so to get this current player, it is returning end, but we need to provide player. So we can have this player.player. So this player.get will get it from here, and it will change the type to the player. Message primitive to int. Okay, so what we can do is we need to provide notify all the player, right? So for that we can have for loop, and we'll update for all. Okay, so let's initialize this. I think we should not take any argument. We can directly initialize this dot players is equal to empty array first of all. Another player should be 0. Okay, we can directly have a star here, which will take care of all that. String position. Oh, sorry, it should be int. No, everything's fine. Interface. It should be public, not class. Interface itself a class. Okay, that's why we should not follow Copilot blindly. Moving on, we can have another class which will be command. Let's quickly complete this. Now inside the command, we can have again same type. We can have interface. Interface can have execute, yes, right. Let's try to uh, have a command which will implement this command. So for the command, I'm thinking of having a function which will take care of all the moving part, moving and onboarding, adding snakes. So for that, we can have class move. So I guess we can have class move command, and which will implement the command itself. That will take. I don't think this much is required, because for moving we want what we need. We want the player, steps, and board. That's it. So we can have private player and steps and board. Let's have a constructor for this. player intent board. That's fine. Okay. So we need to provide the interface. What is this giving? We have execute. That is fine. Execute is overriding. That is fine. And inside it we have a player dot get position, which return position, and then adding that new steps will give a new position. And if new position size is greater than the board size, so after that we are returning the board size itself. We can have board size itself, not needed this much. And if the no, sorry, we have to take care of the snakes as well and ladder. So for that we can have if board dot get snakes, yes, contains, because board dot get snakes will return the map. Okay, and if map, once we get the map, I'll check whether the contains the key new position. If that contains new position, I'll update the new position with the values of that. Same case for ladder. Okay, so I guess till now it is fine. Now we will return the player, or we can set the player. Yes, we set the position with the new position. So till now everything is fine. Let's have quickly strategy pattern. Dice strategy. And strategy also will have this follow the same pattern which we had public interface strategy. Yes, for strategy, dice strategy, we need to have dice roll dice. So it will take care of rolling and returning the random number. Plus normal dice implements dice strategy, which will return. No, not like this. First, we need to initialize normal dice, right? In normal dice, we can have uh, this dot random. I mean, we can provide a random number, right? With new random, or we can have random here because we are basically taking care of dice with a random number. So now we have this random, so we can take random dot next. So it will give any number under 6, and we are taking plus 1. I guess that's it. What is the uh, random cannot be resolved to a type. Okay, what we are doing. Okay, so let's import it. Yeah, now everything is fine here till now. Lastly, we'll have another factory which will be obstacle factory. So till now we have provided the snake implementations, ladder implementations, but we are not creating snakes and ladder. So we have to have that now. So for that we are taking care by obstacle. Basically, it is a factory design pattern. So So till now it was fine. We can have a public, right? Create obstacles. In create obstacle, we can provide or not create obstacle. Why create obstacle? We can have create snakes. In the side is snake. We can provide the board and the snakes list of the snakes. So board because we are adding the snakes or ladder inside the board. So for that we need to have a board. So basically this board will add this snake. So we will call the board dot add snake and provide the head and tail. So we will try to perform that here. So we'll add the board. So I guess I can have int here size. Yes, I guess same thing for ladder. Yeah, same thing for ladder. So till now everything's fine. Now we can have our main class. Okay. So in main class we'll have main where we will provide the implementations. So for that we can have a board or get instance because we are now have to first get it uh, instantiate the board. So for that we have can have a get instance and we don't need to provide that much. The size can be 100. That's cool. And also we need to initialize the snakes and ladder. So for that we can directly add. Okay, so we can directly have a board and create snakes and create ladder. Let's quickly. We have initialized the board. We have initialized the ladder and the game. So let's initialize game as well and then player. So now game will contains take care of the player. If we check here inside this game, it takes care of the players. Whether which player needs to be added, which player needs to notify. So it acts as a observer. It takes care of that thing. So we have the player. We can also add a player. Player one, Alice. Yeah, we can have two player at for now at least, Alice and Bob, and we can add this player in the game because as I told the game take cares of the player. Now we need to also initialize dice. So this part takes care of initializing. So till now we have initialized all of the boards, snakes, ladders, game, players. and dies. Now we need to perform the main operations, which will take care inside this while loop. So inside this while loop, what is this? So inside the while loop, we have a current player, which will fetch me the current player, and I'll have another rice will roll. I mean, dice will roll. We'll get the position and add the position to the new position, but not like this because we already had. If we check here in the command and execute, we already providing the player steps and board. So it takes care of the steps. What will be the steps needs to be provided, and accordingly we can execute that method because once we got this three, we can check whether that position is greater than size, whether that contains snakes. So accordingly, we will get the new position. So we can first initialize. Uh, let's do one thing. Let's remove till here, and we can directly initialize command. Command, yeah, command dot move command. We're providing the current player and role and board, not board. We don't need board. Acha, we need board here. Okay, then why we're taking the new position here? It will take care in the command itself. Then we'll call command dot execute. So it will take care of the new position. Oh, sorry, command. Now since we have a new position, we can notify others that we already got a new position. And this current player is rolled a dice, which we got this number, and now we are moving to the new position. Now we already had this. Since we notified, we can check whether we have get current player. Current player dot gets position is equal to port size. If that is equal, then we says that this particular player wins the game and will break and continue. Otherwise, we will change the turn and this will go on. Till now, everything is fine. So we basically initialized board here. In board, we have instance because we provided the singleton pattern. Now board will contain the size, snakes, and ladder. So the singleton pattern takes care here, but it is for single thread. For multiple thread, we need to provide the locking, and this provide the size. This gets the size, set the size, and get ladder, set ladder. Observer take care of the update thing with the what we need to add a log and all. We can have log here. So it will take care of getting the position, setting, and updating to the logs. Inside this observer, we have a game. So it actually performed the observer pattern here. So we can see it is providing notifying other players, adding players. So it is taking player of the player and as well it is giving current players and other all players. Command is actually providing the request in the form of object. So this is a kind of request, but it's taking care in the form of object. So everything is taken care whether the about the new position or not. So overall, it's taking care over here. Rice strategy, it's just a random number which we need in every role. So for every role, we providing a random number, and it should be between the bound which we provided. Obstacle factory is nothing much, but it is creating this snake. It's just that both have the same method. We can have an abstract level of function over here because we can see both method is performing same implementations. So now in main class, we first initialize all these fours or five, the board, snakes and ladders, some players, games and all, and dice as well. After that, the actual implementation is in here. First we created I mean, we got a player, then we get the current player first, then we roll the dice, we got the dice number, and we pass that to the move command. Inside the move command, everything is get set it. After that, we call execute. So execute will take care of the edge cases, whether that contains the stakes and a ladder. And after that, if once we got this move command, it will return, not return, it will basically set the new position for that particular player. So if we see here, uh, for that particular position, this position has been set for this player. Once we set this position, we notify other players as well that this is the thing has been happened, and we'll also check for our side that if this current position is equal to both sides. Let's say the size is board of is 100, so we the player already reached the top. Now we will say declare that this player is win and will break out of this loop. Otherwise, we'll call the next turn. So next turn will add the player plus one, and we'll check that should not exceed the player size. So that's all in this stakes and ladder design pattern machine coding on. Thank you and see you next time.